Another way that velocity can change is by changing direction. Recall that velocity is a vector. Vx x hat plus Vy y hat plus Vz z hat. So the magnitude of velocity is the square root of Vx squared plus Vy squared plus Vz squared. Right? And this is equal to the speed. Now we know that it's possible for your velocity to stay constant. But at the same time, if it's changing for your speed to stay constant. But if you're changing directions, then your velocity is actually going to change. So for example, imagine if you're on a merry-go-round. Then at any point in time, your velocity's always going to be pointing to a direction perpendicular to where you're moving. The thing is, even though your direction's always changing, your speed can be the same if you're traveling around it in a circle at a constant speed. So we see that sometimes just by changing directions, that's going to change your velocity. Okay, and so also recall, so remember that now Vx is going to be dx dt, Vy is dy dt, and Vz is dz dt. So in your book, they actually use this. They say, well, what if we take some path that's some kind of crazy path like this in the plane? Where we're in a plane, so that this is the y hat direction, this is the x hat direction. So now, even if you're traveling at a constant speed, at any time your velocity is always pointing in the direction that you're moving. So you see that you have a velocity that's changing all the time. And so your book actually uses this to derive our formula for velocity that we got last time, where we said v is dr dt, where they define dr as this very small element, so that we say that we're again going to look at a time that's so small that you're essentially not changing directions in the smallest amount of time. So that's another way to look at how we take an infinitesimal time and get a velocity out of that. So next time, we're going to actually start getting into some real physics. We're about to start talking about the conservation of momentum, which is one of the most important conservation laws of all of physics.